Hey guys, welcome back. We'll continue with the book Automate the Boring Stuff with Python, and today we're going to cover dictionaries and structuring data. You can read the book for free on automatetheboringstuff.com, or if you prefer a physical copy of the book, you find the link to the book in the description down below. Also, if you want to stay up to date about new videos being released, feel free to subscribe to the channel. Let's get right into it. So in the last video we learned about lists and how we can work with lists. Similar to lists, dictionaries are also a mutable collection of many values, but unlike indexes for lists, we can use many different data types as keys for our values. Let's have a closer look at what dictionaries actually are and how we can work with them. In order to create a dictionary, we are using curly braces, and inside of that we are using a key, a colon, and then a value. So the key, for example here size, associates this key here with the value of the string fat in this case. Once we create our dictionary, we can of course display it by just entering its name, and we can also reference different values by referencing the keys. And to reference keys, just as we did with lists, we are going to use bracket notation, and inside of such brackets we are entering the key. The key can be an integer as we see here, and then we're gonna get back the corresponding value, or we can even create dictionaries that, for example, have integers or other data types as keys. So as an example, we are creating a dictionary here which uses integers as keys. So as we type in that integer, which represents a key, we're gonna get back the corresponding value. Other than lists, dictionaries are not ordered. That means we cannot rely that a certain item comes first. Let's have a quick look at an example to make that clearer. Here we have two separate dictionaries which contain the same key values but in a different order. So here we have the key name, which is assigned to Sophie, which is in last position for our second dictionary here. Then we have species and cat, which is in first position for the second dictionary. And then we have a third key value pair that's here in the middle. Now if we compare those two dictionaries to each other, we actually get back the value true, meaning that both of those dictionaries include the same values, so the order really doesn't matter. Now one important thing to note, similar to how we saw that with lists in the last video, where we tried to enter an index that was out of range and we got an error message, if we tried to reference a key that does not exist in our dictionary, we are also going to get an error. So here we get the key error color, which tells us that the dictionary X actually does not have a key called color. Now, even though dictionaries are not ordered, the fact that we can associate a value with a specific key is quite powerful and gives us some additional capabilities beyond what we already can do with lists. Let's have a look at an example. Here we have a small program that displays the birthday of different people. We have a dictionary called birthdays, which has keys that correspond to people's name, and then as values we have their birthday, and all of that is mapped in strings. We are then using a while loop, and we ask a user to enter a name. If they provide an empty string, then the program is gonna quit. If they provide any other value, we're gonna keep on looping in our while loop. Now if the name that has been provided is an element in our birthdays dictionary, so similar to how we did this with lists in the last video, here we can also check if a value is inside of a dictionary. So if that's the case, then we're going to print out the birthday of the person by passing the name that has been provided as a key to the birthdays dictionary, which gives us back the specific date. And then we write is the birthday of, and we use the name of the person. Otherwise, if the name is not in the list of birthdays, we print out that we don't have any information about that, and then we're actually modifying our dictionary and adding the birthday to it. So we allow users to enter the birthday, and then by using this notation here, where we take the name of the dictionary, then brackets and the key, which is the name, and we associate that with the birthday, we're adding a new key value pair to our birthdays list. So let's run our program. And let's first enter a name that's actually in the list of birthdays. So Alice here is the key to this key value pair in our dictionary. So here we get back April 1st is the birthday of Alice, which is of course correct. But now let's enter a name that's not in the list. Let's enter Eve. And we get back the information that we do not have any birthday information for Eve, but we can provide that information. So let's say her birthday is on December 5th, and our database has now been updated. So the key value pair Eve as a key and December 5th as a value has been added to our dictionary. And now we can go ahead and type in Eve again. And now we see that December 5th has been saved, and it's actually the birthday of Eve. Now, importantly, that information is of course not persisted. So once we stop execution of our program like this and we restart it, then we would have to add Eve and her birthday again as a key value pair. We are going to learn in a later video how we can actually persist that in a database. There are a number of different methods we can use with our dictionaries, and three of the ones which are quite frequently used are the keys, values, and items method. And all of these three methods return list-like values of either the dictionary's keys, values, or key value pairs. Let's have a look at an example. Here we have a dictionary spam that has two key value pairs. And now we can go ahead and we can actually loop over the different values. So red and 42 here, by saying for the value in spam.values, which is a values method. So it's going to return the values inside of our spam dictionary. And then we're going to print that out. So here we see we get back red and 42, which are all the values in that dictionary. In a similar way, we can also go ahead and print out all the keys. So here, taking our dictionary again, we can say for a value in spam.keys, we are going to print all the keys. So now we get back color and age. So this is how we can get the values and the keys respectively of a dictionary. And finally, we can also get back an entire key value pair by using the items method on our dictionary. So here we are looping for all the items in spam.items and printing those out. So this is going to give us back the key value pairs, which are basically returned in such a tuple. Similar to lists, we can also check if a certain value is inside of a dictionary. So here, for example, we can check if the key name is in spam.keys, which of course is the case. So therefore we're going to get back true. We can also check if a certain value is in the values here in our dictionary, which in this case is also true. And of course we can also do the reverse, so we can check if a certain value is not, for example, in the list of keys of our dictionary. Now it can get quite tedious to check whether a key exists in a dictionary before accessing that key's value. And that's where the get method comes in, that is available for dictionaries. And that takes two arguments, the key of the value to retrieve and a fallback value to return if the key does not exist. So let's have a look at an example. We have a dictionary here called picnic items that has two key value pairs. And then we are saying we are bringing a certain number of cups to the picnic, and we are using the get method on our dictionary here. And as the first argument to the get method here, we pass cups to it. And if there's no value associated with the key cups, so if that key does not exist, then we're going to return a value of 0 instead. So in our case here, we have cups as a key in our dictionary. It has a value of 2. So as we run that, we see we are bringing 2 cups. But if we update our dictionary and we remove that key value pair with cups in it, then we get a different output. Now in this case, there is no key value pair with a key of cups inside of our dictionary. So as we run that, we get back, I'm bringing 0 cups rather than an error message. So the get method can be really useful. Now, quite often we may check for a certain key, and if that key does not exist, we want to add a new entry to our dictionary and add that key and the associated value as a new key value pair. And while we can of course check if that key exists, and if it doesn't exist, we can then add it to it, there's a method in Python that can be a useful shorthand, and that is the setDefault method. So here we see an example. We have a dictionary spam with 2 key value pairs, and then we call setDefault on spam, and setDefault takes 2 arguments. The first one is the key to check for, and if that key actually exists inside of that dictionary, then we are going to basically just retrieves the value associated with that key. However, if that key does not exist, then we are setting the first argument, so color in this case, as a new key, and the second argument here is going to be the value that's associated with that key. So in this case here, there is no key of color inside of our dictionary. So as we run that, we basically set this, and if we run spam again, we can see we have an additional key value pair color, and then the second argument black is associated as the value. So the set default method can be a really handy shortcut to ensure that a key exists. Let's have a look at an example. And here we want to count the characters that are being used in a sentence. And we want to figure out which characters are being used and how often they are used. So we have the string message with the sentence here. Below that we have an empty dictionary. And then we are looping through each character in our string. We know we can do that because string is a sequence data type, and we can loop over it similar to how we could loop over entries in a list, for example. And then we call set default on our empty count dictionary, and we pass in the character that we're currently looking at. So for example, I and then T. And if that character does not yet exist, we set a value of 0 to it. And of course, if the character already exists inside of our count dictionary, then we are not setting it to 0, but instead we are then increasing the value by 1. And at the end we are printing out our count dictionary, so by the end of it we should get back a dictionary that has characters as its keys, and then the value would be the number of times that specific character is being used in this sentence. So as we run our program, we see, for example, that capital I occurs 1 time, T occurs 6 times in the sentence, and so on and so forth. So that's a very handy way of how we can use the set default method. To make the output look a little bit nicer, there's actually a separate module that we can use, the pprint or prettyprint module in Python. And if we import that, we use the same code, but at the end we are saying we're calling the pprint function in the pprint module. We get a slightly nicer output. So in this case here, we always have a new line entered, so we can see how many white spaces, for example, are in the sentence, and then alphabetically sorted we get the other output here, for example. So capital A occurs 1 time, and so on and so forth. We can use data structures such as dictionaries to model real-world things. So for example, in chess, there's something called algebraic chess notation that's being used to keep track of where the different pieces are. So we have the letters from A through H, and we have the numbers from 1 through 8 to denote where each piece is. And then also each piece has a certain abbreviation. So for example, we could create a dictionary and putting a key of 1H as a key, and then as a value we can enter the name of the specific chess piece. So for example, the black king is the value here for this particular field. And we can do the same for all the other pieces, and then we have a unique way of identifying what the current position on the chessboard is. Let's have a look at a slightly simpler example. If we play a game of tic-tac-toe, we can also use data structures such as dictionaries to keep track of which slots have already been taken. So here we can model a tic-tac-toe board, and we can model those 9 fields, and then also keep track of whether a field is blank, if there's an X on it, or if there's an O on it for each respective player. And let's write a short program to actually keep track of the game itself. So we can model the board as we saw before by using a dictionary. So here we are using different keys for the different position on the tic-tac-toe board. So if we look back here, we have, for example, the top left, the top middle, and the top right. That's being represented by different keys. And in the beginning, all of the fields are going to be empty. So that means we are using just space character here, which represents the different positions. Then we have a function here that sets up our board. So here we are printing whatever is associated as a value for each of those keys, for the top left position, top middle position, top right position, and so on and so forth. So in the beginning, that's going to be empty. And in the middle of that, we are just entering a vertical line. And then after each of those rows, we are separating that so we have a nice board that's being displayed. And after that, we then have a for loop here that's going to loop until basically all of the fields are filled up. and we are asking the user to provide which space they're basically want to use. And we can enter the key of that specific field as an input, and then depending on the turn, either an X or an O is going to be added. And after each loop, we are printing out the board to show the updates, and then at the end we are going to print the entire board. So let's run our program to have a look at that. In the beginning we have an empty board that's displayed here, and then we have the first turn for a player who plays X, and we ask which field should be taken. So here we can enter the key of our dictionary. For example, maybe we want to take the middle. So we tap that in, and our board will be updated accordingly. Now the other player can play, so they can fill out a field, and maybe they're going to select the top left. So now it's player X turns again. They're going to take the top middle position, and so on and so forth. So that's a very simple way of how we can use dictionaries to represent the data that we are working with, and then to update that accordingly. Now the tic-tac-toe board is fairly straightforward and a very simple way of representing those positions in a dictionary. Similar to how we saw that with lists, we can also nest dictionaries. And here we have a short program that shows that. So we are organizing a picnic. We have a dictionary here with different keys and values. On those values themselves, again, are dictionaries. So the dictionaries are nested within those dictionaries. And then we basically have a function here that's keeping track of who brought which items. So here we are using the items method to get back the key value pairs for our dictionaries. And then we use the get method to get back the item. And if the key does not exist in that particular dictionary, then we're going to set a value of 0. And after that, we are going to print out the different items that have been brought. So apples, cups, cakes, ham sandwiches, and apple pies. And we get this output here. So for example, 7 apples have been brought by the different people attending that picnic, but no cakes have been brought. So that's one way of how we can use nested dictionaries. Now let's have a look at the practice questions. The first one is, what does the code for an empty dictionary look like? So an empty dictionary will be represented by open curly braces and closed curly braces without anything inside. So those curly braces always indicate that we have a dictionary. What does a dictionary value with a key foo and a value 42 look like? So in this case, again, we are using curly braces, and as a key we're using foo, then a colon, and then the value. And then of course later on we could access that value through the key by typing in the name of the dictionary, followed by the key in brackets, for example spam, and then the key foo. What is the main difference between a dictionary and a list? So dictionary stores key value pairs, and the keys can be of different data types, for example integers, but also strings, for example, and they are not ordered. A list, on the other side, is always ordered, and the implicit key is always the index, it's always an integer. And therefore dictionaries give us quite a bit of flexibility, because the order within the dictionary doesn't really matter. We can easily add additional items using the key and value and then just access it through the key. Now what happens if you try to access the key foo inside the spam dictionary, if spam actually doesn't have a key like that, but the dictionary looks like this, a key of bar and a value of 100. So let's create this here. And as we call a key that doesn't exist, we of course are going to get a key error here, because foo is unknown, it's not a key inside of our spam dictionary. If we want to avoid such an error, of course we could go ahead and we could use the get method instead. In this case we don't get an error, but we get nothing back in this case, and we could alternatively pass a second argument to the get method and return that if there's no value associated with that key in our dictionary. If a dictionary is stored in spam, what is the difference between the expression cat in spam and cat in spam.keys? So by default, when we check for whether a certain string is in a dictionary, we are always checking the keys when we say cat in spam. So therefore there's effectively no difference between the two calls. If we have a look at an example, let's say we have this dictionary here with a key of cat and a value of Susie. And now if we check if cat is in spam, we get back true because this is a key. And of course, when we check whether cat is in spam.keys, we are explicitly checking for keys, therefore this is true as well. If a dictionary is stored in spam, what is the difference between the expression cat in spam and cat in spam.values? So there's a difference here, of course, because cat in spam, as we saw before, is implicitly always checking for the keys, not for the values, so there will be a different return value. So let's have a look at this dictionary here. Now, in this case, the cat is a value in the dictionary, not a key. So if we check whether cat is in spam, we are implicitly checking for whether cat is a key to our dictionary, which is false. But if we check whether cat is in the values of spam, we get back true, because that's of course the case. Now, what is a shortcut for the following code? Here we are checking if the key color exists in spam, and if that's the case, we are going to assign a value of black to it. We can do it this way, but we learned about the setDefault method before, and that is a shorter way of actually writing this. So in this case, we have a dictionary spam that does not have a key of color inside of it. So therefore, we are using that setDefault method here. We are checking whether there's a key of color. And if that's the case, we are returning the associated value. If that's not the case, we are going to create a new key value pair to our dictionary with a key of color and a value of black. So now if we have a look at our dictionary again, we can see that indeed a new key value pair has been added with the specified values. And finally, what module and function can be used to pretty-print dictionary values? So we learned about the pprint module that we can use. So we can go ahead and import that, and then we can go ahead and call the pprint function inside of the pprint module. And this is a way of formatting our output a little bit more nicely than the default print method does. In this video, we learned about dictionaries and how they can be useful to model data structures, such as a chessboard, for example, or a tic-tac-toe game. We also learned about important methods to use with dictionaries. In the next video, we are going to cover how to manipulate strings. Subscribe to the channel to stay up to date, and see you guys in the next video.